The Freescale Cup presents students with the opportunity to work in teams and design an intelligent racing car that can go around a track by following a 1-inch black line on a white surface. At the end of the day, the team with the fastest time in 2 trials wins.
The Freescale Cup was a challenge to all of us. Here at the Faculty of Mathematics and Computer Science, we are 3 teams that work very hard to achieve great results. We were very enthusiastic even from the beginning when we heard about the contest, and we decided to make it a big success. It wasn't a challenge just from a technical standpoint, but also we had to work very well as a team.
Well, as the saying goes, if there's will, there's a way. And in the end, we found a way to get past our differences and achieve our goals.
To get started, Freescale gave us a kit comprising of a sensor, a chassis, wheels, 2 motors, a servo, a control board and motor driver. We added a plastic board on which we mounted the microcontroller and motor driver, and the metallic plate on which we mounted the camera and LEDs for better camera inputs.
We made some improvements to the car too. We added a comparator between the camera and the main board. The good part is that it's much faster than the ADC converter. Instead, we cannot dynamically adjust the algorithm depending on the lighting conditions. We need to calibrate the car at the beginning of each run. We also added 4 LEDs to light up the track. It offers us higher contrast and helps us a lot when we are dealing with interior lights.
Essentially, what the intelligent car does is loops a series of actions all along the track until it finishes 2 laps, and then it stops. Firstly, the camera reads a series of values, which are light intensities. High data values obviously correspond to the white environment, low values for the black line. These values in this data is then processed inside the main board, and a series of coefficients are calculated. The car will later respond to what is called a PID controller. Essentially, what this means is that we combine these coefficients to result in various actions such as sharp turns, braking, or accelerating in straight lines.
The main challenge of this competition was the camera. Freescale provided us with a sensor array. The type of camera we're using has an internal interface. It reads data and it sends values from 0 to 5 volts. For reading data, we use an internal ADC converter.
To distinguish black from white, a camera needs a very large amount of light. Therefore, we add some LID to improve data acquisition quality. The second method to improve data acquisition quality is to calculate, for example, first 3 values from the ADC and then divide it by 3.
Thank you, Freescale. See you in Prague. Bye.